Hi, welcome to ESP32 tutorial from Robojax. My name is Ahmed Shamshiri. I'm presenting this tutorial from Canada. In this tutorial, we are going to learn about the fading and pulse width modulation of ESP32 to dim or brighten the LED. And we'll show you how to calculate proper resistors so you can put two LED in parallel. 1.3 divided by 10 milliampere and we get 130 ohm resistor here. And I will show you how to fade two LEDs. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. Fading or dimming an LED is not straightforward as the Arduino products. With ESP32 we have a different method, and you have to take some thing into consideration in order to be able to fade an LED. Now each LED that you connect, depending on the characteristics, generally they are about 2 volts, maybe 1.9, 2.1 up to 2.1 volts, but in average we can say this is 2 volts, and the output from the ESP32 is always 3.3 volts. All these pins that are outputting, they are 3.3 volts. So if you connect it directly to 3.3 volts, the LED will get damaged. Sometimes immediately, sometimes maybe within a few minutes or maximum an hour or so, they get damaged and they will burn. So you have to put a limiting resistor as a divider. We talk about the LEDs first. The LED will have anode and cathode, and here this side is anode, the side that has a line is cathode. Anode is always connected to positive and the cathode is always connected to negative, meaning this side should always have higher potential or higher value of voltage than this side, than the cathode. Longer pin, so this is anode, and the other side, the shorter, is cathode, meaning the longer pin is connected to positive, the longer pin is connected to positive, and the shorter on the other side. Now here this is a positive, and it passes through a resistor, goes to the anode of the LED, and from the other side it goes to the ground. This shows 5 volts, but in our case it will be 3.3 volts. We have a resistor, the voltage comes from the pin, which is 3.3 volts. It goes through the resistor and enters to the anode of LED, and the LED will turn on and it goes to the ground. So this LED is in average 2 volts. So whatever voltage you have, 2 volts will appear across this, and the remainder must be divided over a resistor. In this case, if we have 3.3 volts, then 2 will be here. We have 1.3 volts left here. And also, depending on the brightness and the size of a LED, usually we consider 10 milliampere for these 3.3 millimeter or 5 millimeter LEDs. So we have 10 milliampere. Now by Ohm's law, if you see here that this resistance is R is equal V over I. R is equal V over I, and the voltage, this is 2 volts, 1.3. The voltage is 1.3 divided by 10 milliampere, and we get 130 ohm resistor here. So if we put 130 ohm resistor, 1.3 volts will be here and 2 volts will be here, and the LED will lit properly. Of course you can put higher resistance here, but the LED will not turn properly. Here the positive comes, this is connected to pin 5 of my ESP32. It says G5, and the other side is connected to the ground, or GND. So from here I'm putting, assume this is my pin 5, 3.3 volts come, and then I have here 150 ohm resistor. I'm supposed to put here for one LED 130 ohm. I don't have it in hand. This pin goes to pin 5 or G5, and then a resistor, and then the longer pin that you see here will be towards the resistor and at this line, and the shorter pin at this line which this goes to the ground. So I'm inserting the longer pin in this side, like this. I will reply to all comments and questions of my channel subscriber. Make sure to subscribe and leave the notification on. Now, to get started using ESP32, your Arduino IDE must be prepared and the driver for ESP32 must be installed. I have a separate video explaining how to do that, but if you have not done it, click on File, Preferences, and in this URL, this is the previous one, you can enter another URL by clicking here and press enter and paste this URL that I will provide you in the description or the link. Once you do that, click OK. Now go to Tools, Boards, and click on Board Manager. Wait for this until this is completed. And in here type ESP32 and you will see ESP32. Mine already has it, so it says remove. In your case, you will see install. Click install. It will take few seconds or maybe a minute until the board is installed and completed. After that, you also, when the board is connected, make sure to select the port, go to Tools, Port, and select the right port that is for your board. And after that, then you will be able to see the examples. Click on File, Examples, then go to ESP32 and here Analog Out, LEDCs, Software Fade. If you click, this will open. Now, the explanation is that we have to define a channel for this purpose. So LEDC, we have 16 channels, so we start from 0 to 15. So we put here 0. If you have multiple LEDs, just increment it and go to the next number. So this is now referring to 0, and also number of bits that you want to increment the fading. So 13-bit, so this is a 13-bit, and we will use this one in the code. And the frequency also can be selected. 5000 hertz or 5 kilohertz also works fine with LED. So this, we are defining our frequency with this variable, and this is the value. And this is the pin where we connect our LED, in this case pin 5, and that is printed as G5 on the board. So if you are using any other pin, you can do so here. After that, this is the brightness of LED, so this holds the value. Initially it's 0. Fade amount, that is 5, meaning that every increment it will go the value of 5. And here this void LCD analog write, this is a function that starts from there and ends here, will take care of the calculation, which I'm going to explain next. And here inside the setup, LEDC setup, we pass the channel, we pass the frequency. These are comma, which means we are passing it to the LCDC. This is internal function with ESP32 and LCD timer bit. So we need these three so it can start working. And then we will attach LED pin 5 to the channel that we defined above. The setup is now done, and inside the loop, LEDC analog write, we pass the channel and the amount of brightness. Now pay attention to this loop. It gets the brightness and then the fade amount, which was 5. 5 plus 0 is 5. Now the brightness will be 5, and you see the loop will go in here and the brightness will be 5. This portion is taking care of the value. If the value is lower than 0, or these two pipe or vertical line are called pipe, meaning or. If brightness is bigger than 255, then we go in the other direction, meaning we change the fade into negative. So brightness minus the fade will go backwards. So first it goes from 0, 5, 10, 15 up to 255, and from 255 it goes back to 0. The job of this section is to not allow it to go above the value, and it reverse the direction. And we have 30 milliseconds delay, and the loop will continuously send the command. Now this was the command that is taking care of it, so we pass two values, the channel, with channel, and the amount of brightness, and here that is the function. LED analog right is here. We are passing, this can take the two values here. This is the LED channel, and this is the fade value, and this is the maximum already set here with the default value. So we are getting those values, and we do the calculation because we set 2 to the power 13. We set the bit value here 13. So here is 8,191 divided by the value, which is 255, multiplied by minimum of the value. So this ensures that we get the right value, and it gives us the duty cycle. And job of this portion is that because the maximum value is 255, we use the function min or minimum. You give it two value, and it takes always the minimum. And because this is 255, and the value that we pass here, if it is less than 255, then it will be taken. If it is above 255, then this will be minimum, this will be maximum. So this function will take the minimum, the smallest value, and multiplies it by this factor, and then we get the duty cycle. And then it gives us a duty cycle, and then this is the function that writes the value to the pen, channel and duty. The duty have been calculated. The channel is coming from here to this, which we pass here LED channel 0. So this goes to the channel and applies the duty cycle continuously, and LED will fade and brighten, fade and brighten. And here in this case, I've used for one LED. If you do the calculation, it's 130 ohm, but I have the closest one is 150. Do not go lower, go a little higher. It will be a little dimmer, but still better to protect the LED. Now, when you connect two LEDs together, then the amount of current will be doubled, and the voltage drop will be here higher. So we have to reduce it. Now, in this case, now this was 10 milliampere. Now we have 20 milliampere. 20 milliampere will pass. So here 1.3, again 1.3, because if you put two of this together side by side, still it's 1.3 volts. So R is equal to 1.3 divided by 20 milliampere. It will be 65 ohm. And here I'm going to put 68 ohms. And it will be now much brighter and properly biased or voltage divided. Now let me explain the code for fading two LEDs, an LED C channel 0, and also I have added another one. I call it 1, and I've added channel 1, so at the end I've added 1. The resolution or bit is the same in terms of precision. The frequency is 5000 Hertz. I've not changed it. And here LED pin, I have added 0, that's a pin 17. For LED pin 1, 16. And here this can be the same brightness, 0, brightness 1. I've added brightness for 2, so you can control them separately. And amount of fade, I've used 5 for the first LED and 10 for the second one. And this function is exactly the same, because this function will take any value. And inside the setup, this was the line, and this was 0, pin 0 I've added, and channel 0. So this is the same constant variable in both cases. And I've copied and pasted one more time here, and here we have passed the LED C channel 1 in both cases, and also LED pin 1. And this was inside the setup. And inside the loop, here is how we fade it. LED C analog right, LED C channel 0, and then brightness 0. And then for the second one, it's with 1 at the end. And for the fade also I've added one more line, and here to control the amount of brightness, for the brightness 0, and I've added brightness 1. I've just copied this here, and I've added, and that one I added 0 at the end of all of them, and here it's 1. So as simple as that. And here is an example of fading two LEDs, and one is fading at a step of 5, the other one is changing this step of 10. So this is fading faster and that's slower with ESP32. I've added another resistor and LED, and the ground is connected through this wire. And here for the wiring, the ground from this point, and here the ground is connected to the ground. This red is connected to pin 16 and the white is connected to pin 17. So these two are used for that purpose. Thank you for watching. This was how to do the fading or dim LED using ESP32 microcontroller Bluetooth Wi-Fi module. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it in the comment section below, and if you are my subscriber, I will always reply to your question and comments. If you want to get updates of my upcoming videos, make sure to subscribe.